Hello. So today we are going to discuss the step response of this first order RC circuit. So suppose in the interview you are given this question, like this is the first order RC circuit, and you have to tell what will be the waveform of the output voltage, the voltage across the capacitor when we apply a step voltage of 5 volt. Let us consider the initial voltage of the capacitor is 0 volt. So now let's analyze this circuit. Before analyzing this circuit, we have to know the property of a capacitor. So the capacitor can't change its voltage instantaneously. Okay, so to change its voltage instantaneously, uh, the capacitor must have a uh, impulse current to it input, otherwise it can't change its voltage instantaneously. So capacitor will hold its voltage for some amount of time, then after that it will change its value. So we can't change the capacitor voltage instantaneously. Now in this circuit, if we look at t is equal to 0 minus, what is the voltage of the capacitor? In this point no input is applied and the initial voltage of the capacitor is 0, so the voltage of the capacitor at t is equal to 0 minus is 0 volt. Now at t is equal to 0 we are applying a step input in this circuit. So according to the property of the capacitor, that it can't change its voltage instantaneously, so at t is equal to 0 plus, what will be the voltage of the capacitor? Still it will be 0 volt. Okay, like just after crossing this point, okay, the voltage of the capacitor is 0 volt. So what is happening actually, if I talk about in frequency domain, in this is our step signal, this is the transient phase, transient, and this part is the steady state. Here in the input there is a sudden jump in the input value. So at t tends to 0 plus, we can say the input signal frequency is infinite, and we know the value of the capacitive reactance xc is equal to 1 by j omega c. So as omega tends to infinite, then the value of the xc tends to 0. So in that way, by using a voltage divider, you can say that, like for t is equal to 0 plus, the voltage of the capacitor is 0. And initially what happened, the capacitor acting as a short circuit, and then gradually capacitor starts charging. Okay, so gradually capacitor voltage increases. So at t is equal to 0 plus, omega tends to infinity, and the voltage across the capacitor is 0 volt. Now as the time increases, the capacitor gradually charges and its voltage increases. So suppose at t is equal to infinity, what happens? The circuit, the input achieves steady state. There is a no fluctuation in the input, so you can say its frequency tends to 0. So in that case, xc tends to infinite. So capacitor acts as an open circuit and total voltage will drop across the capacitor. So what will be the voltage? Vc infinite will be 5 volt. So now if you look in this way, like at t is equal to infinite, what happened? The capacitor from t is equal to 0 gradually charges. At t is equal to infinite, the capacitor charged to 5 volt. So there will be no current flowing through the capacitor, and capacitor voltage will remain at 5 volt. So if you want to find like what is the equation of the capacitor voltage, so you need these two value, Vc at t is equal to 0 plus and Vc at infinite, and we know the voltage of the capacitor Vct is equal to Vc of infinite plus Vc of 0 0 plus minus Vc of infinite into e to the power minus t by tau, where tau is the time constant of the circuit. Here tau, the value of the tau is RC. Okay, so now if we put the value, we will get 5 plus 0 minus 5 into e to the power minus t by tau. So 5 1 minus 5 into 1 minus e to the power minus t by tau into ut, because this whole process it start after t is equal to 0. Okay, so now this is the voltage across the capacitor. Now what will be the equation of the current? So initially, what is the value of the current? At t is equal to 0 plus, this capacitor behaves like a short circuit. So here the potential is 0 volt. So initially, what is the value of the current? IC 0 plus. Initially the value of the current is 5 by R, and at steady state the capacitor charged to 5 volt and input is also 5 volt. So total current is how much? 0 ampere. So IC of infinite is 0 ampere. So now what will be the equation of the current? ICT. So we can write like IC infinite plus IC 0 minus IC infinite into e to the power minus t by tau. So its value become 5 by R into e to the power minus t by tau into ut. Now how the waveform looks like? So this is the waveform of the output voltage Vout. So it will increase like this, where the time constant t or tau is equal to RC, and at steady state it will reach to 5 volt. And how the current waveform looks like? The current will decrease exponentially and the output waveform will look like this. So this is actually the response of a simple RC circuit when we applied the step input. Now what will be the waveform across the resistor of its voltage? We have to find out. So initially at t is equal to 0, t is equal to 0 plus, here the capacitor behaves like a short circuit. So total voltage will appear across the resistor. So at t is equal to 0 plus, the voltage across the resistor is total 5 volt, but at t is equal to infinity, what happened, the capacitor is fully charged to the 5 volt and input is also 5 volt. So here current flowing through the resistor is 0 volt. So at t is equal to infinity, the voltage across the resistor is 0 volt. So simply the equation of the resistor voltage will be 5 into e to the power minus t by tau ut. So it will reduce exponentially from its initial voltage of 5 volts. So in this way you can analyze the simple RC circuit. Now what is its pole value? Okay, so the pole is nothing but the reciprocal of the time constant. So in this circuit its value is 1 by RC. So in this circuit, is there um, any possible value of the is there any possible value of 0? Can you check? So to get 0 in the output, either we have to make R tends to infinite, so which is not possible in this circuit, or we have to make C is equal to 0. So the I mean to say, like the value of the capacitive reactance to 0, which is possible at omega tends to infinite. So there is no 0 in this circuit. So here um, only one pole present in this circuit. And what is the value of DC gain of this circuit? So if you are asked to find the DC gain, what you do, just put frequency as 0, or in steady state frequency is 0 and capacitor acts as a open circuit. So what you give at input, you will get that signal at the output at a gain of 1. So there will be no attenuation in the signal. So in this circuit the DC gain is 1. Okay, but for different circuit DC gain might be different. Like if I connected a resistance here, so when omega tends to 0, the circuit will simply behaves like a resistor divider circuit. So here the DC gain will be R by 2R, so DC gain will be half. So depending upon the configuration of the circuit, the value of the DC gain pole changes. Okay, but in this circuit also there is no 0, because to make this part to make this part 0, we have to go to infinite frequency. So which is not possible. So physically there is no 0 present in this circuit. Okay, so now you can analyze this circuit with a step input 5 volt, 0 volt at t is equal to 0. Similar way that I solved the previous circuit, and let me know what is the expression of the output voltage, with taken with respect to the resistor, and what is the expression of the current I total. Okay, so please let me know the answer in the comment. So thank you for watching.